Hello students, in the last session we completed around 8 sums. The sums were mainly based on graph. So we have to generate the formula and then we'll have to match it with the graph that they have given in the question. So those were like a little bit tricky and they were different pattern sums actually. And then we saw sums related to the average velocity, and then you had a plank, and we just need to find the number of plank that was needed to stop the blood. Okay, so all those questions were related to those kinematic equations. Got it? You'll have to be familiar with those kinematic equation, and you should have that critical thinking to to use those kinematic equation in a different pattern to solve the question, right? So that's what they expect in the JEE examination. This will be the final session for this PYQ part for this first chapter, which is going to be the motion in a straight line. Okay, so even in this session we will do around 7 sums. These sums will also be related towards those kinematic equation. I have put around like 5 sums that will be from the numerical part. So those sums will also be easy, similar to that of the sums that we have already seen, right? So only thing is you have to get those number and fill it in the blanks, right? So obviously we know this is a computer based test, so you have to type those values in the computer, right? Got it? Fine. So in the session we will do around like 7 sums. With that, almost all the different pattern sums that were related to this first chapter is done. Got it? You have to be clear with all these different pattern sums that I've taught you, and then the different solving that we did. Okay, so if you are just thorough and you had a good understanding of the solving that I did, most probably you will be able to do, yeah, majority of the question that they're going to ask in this chapter, right? So you will get that intuition, how should you actually solve. Got it? Fine. So let's jump into the next question, which is going to be the 25th one. In the session also you got like 7 sums that we will do. Got it? Yeah. The 25th question is, a train starting from rest first accelerates uniformly up to a speed of 80 km per hour for time t. So you've got a train that's undergoing an uniform acceleration and it reaches a maximum speed of 80 km per hour. Got it? And the time taken is going to be 3t. I mean t, only t. Then it moves with a constant speed of 3t. Fine. So then it is going to move with a constant speed of 3t. The average speed of the train for this duration of journey will be, yes, yeah, this is also the same kind of sum where we are going to find the average velocity, but then given you, yeah, they've given you a little bit in a trickier fashion, something of that sort. Got it? First, let me draw the diagram for the question that they've given. Got it? So you got a train that's going to accelerate uniformly, and then it reaches a final speed of 80 kilometer per hour. Okay, right? The average speed of the train for this duration of the journey will be in kilometer per hour. So even the options that I have given is also has to be marked in kilometer per hour. So I do not want to worry about the unit conversion over here. Okay, it doesn't make any sense. Got it? Fine. So what was the time taken? The time taken will be equal to t. Got it? In the next part of the journey, it's going to travel with this constant speed, which means it is going to have the same speed that will be 80 km per hour, and then it is going to travel a distance of 3t. Got it? What they're asking us to find is what will be the average velocity for this entire journey. Got it? So to get this average velocity for this entire journey, the trick is the same thing. Got it? You have to get the total distance and then you'll have to divide it by the total time. Let me put it in this fashion. The initial distance that got covered in the first part of the journey was S1. Same way in the second part of the journey, that's going to be S2. The time taken will be like T for the S1 and then 3T for the S2. Got it? Then what should be its average velocity? It has to be the addition of those two displacement, which will be S1 plus S2 divided by the total time taken. The total time taken is obviously 3T, right? So T plus 4T. 3T plus T. Got that? Okay, fine. This is done. Now what I need to get is I just need to get the displacement S1 and S2 in terms of T so that I can cancel those stuff. Got it? So first, let me look into the first part of this journey. In the first part of the journey, the initial velocity was 0 because it started from rest. The final velocity was like 80 kilometer per hour, and then the time was t. What I need to get over here is actually the distance s. So if I have to get the distance s, what will I be able to use? I'll be able to use like v square minus u square. That's going to be like 2as. In that situation, I just know the initial velocity and then the final velocity. That stuff is done, but I do not know the acceleration over there, isn't it? So to get that acceleration, what can I do is, I just know the time t, isn't it? So if I know the time t, v equals u plus at. From that relation, I'll be able to get the acceleration. Once I get that acceleration, let me put it into this equation v square minus u square, which is going to be like 2as. From that, I'll be able to get the distance s1, right? So let me solve it, you'll get it. Fine. So here you've got v equals u plus at, isn't it? So the final velocity was like at, that will be equal to u was 0, a, that's something that I need to find. The time taken in this journey was like t. Acceleration a will be equal to at divided by t. Now I have got the acceleration. Then I just need to get the s1, right? So to get the s1, it will be something like this. S1, which will be equal to, yeah, let me put it in this fashion. V square minus u square, isn't it? So here v square, final velocity was like at square minus u square, that will be like 0, which will be equal to 2. Acceleration a will be at divided by t, and then you would have got the s. So the s over here is actually s1. Got it? Yeah, this one has to be clear. Then what should be the s1? So here you've got 180 and 80 will get cancelled. Then you have got 2, this will give you like 40 over there. So let me do the multiplication. S1 will be equal to 40 multiplied by t. So S1 is equal to 40t. Okay. So this S1 is done. Got it. Next you have got, so the first part S1 is done. Then I just need to get the part S2, isn't it? So to get this S2, what should it be? It's going to be the constant velocity. So the constant velocity is like 80 kilometer per hour. And then I just have to multiply it with the time. So once I do the multiplication of these two stuff, I'll get the S2, isn't it? Straight away one. So S2 will be equal to 80 multiplied by 3t, right? So 80 multiplied by 3t, that's going to get you 1624 to 40t. Okay. Now I've got the S1 and then the S2. Then I just need to get the velocity. So to get the velocity v, average velocity v, that's going to be 40t plus 240, no, 240, isn't it? Yeah, 240t divided by the time taken. So the time taken over here is 4t, isn't it? So what should it be? 240t. 40 plus 240 is going to get you 280t divided by 4t. Let me cancel it out. Tt will get cancelled out. Then this should have been 28, isn't it? Therefore, yeah, 7 is, yeah, 7, yes, 70. So the answer over here is option 4, which is going to be 70. Yes, the answer here is 70. You should be clear with this question. Simple sum. So they have given you, they're asking us to find the average speed or the velocity. So to get that average speed, just use the kinematic equation and get the total distance that has been covered. You'll get like S1 and then the S2. Once you get these two distances, just add it. That gives you the total distance divided by the total time taken, which is going to be the 40, right? Just do the solving, you'll get the answer. Got it? You should be clear with this question. Simple one. Let's move to the next one. Next question is, a car starting from rest accelerates at the rate of f through a distance s. Got it? So what they've given is, there is a car which has an initial velocity 0. Yeah, it is starting from rest and then it undergoes acceleration at the rate of f, which means the acceleration a over here is this small f. Because of this acceleration, it has covered a distance s. So that's the first part of the journey. If you have to draw a diagram for it, you have got something, car that's going to accelerate. So the acceleration over here is like f. This is the acceleration over here. Because of this acceleration, it has covered a distance s. Got it? So this will be the first part of my journey. Then what they've given is, then continues at constant speed for time t and then decelerates. Got it? So then you have got like, then continues at a constant speed for time t. So in the first part of the graph, they have given us, in the first part of this motion, they have given us the distance. In the second part, they have given us the time. Okay, so when you look at the second part, they have given us the time. Got it? In the second part, the time taken was like t and the velocity was the constant velocity, which was the velocity with which it has reached the last part of this first segment. Got it? Okay, so with this final velocity, it's going to travel with the constant velocity. So the velocity is going to be constant. Let me put it V, whatever it is, let me put it V. I'll just figure out it afterwards what it is going to be. Anyway, then what has happened is then decelerates at the rate f by 2 to come to rest. Okay, so this is an important part over here. What is happening over there is it's going to decelerate at the rate of f by 2 and then it comes to rest. Got it? So in the second part of the motion, in the third part of the motion, it is undergoing deceleration. The deceleration is such that it's going to be like f by 2. Got it? But they haven't given anything related to the distance that it got covered, but it is a hidden thing that we could actually find out by using this f by 2. Got it? So the third part of this motion is something like this. Yeah, I'll use green itself. So the third part of the motion is you are gonna have the acceleration f divided by 2. Got it? So then what should be its s? That's what I need to get over here. First, let me figure out this distance s. To get this distance s, just by logical thinking, you should get the answer s, because that's gonna be double the time, isn't it? So it has accelerated and then it covered certain distance s. Got it? Then the deceleration was such that half of its acceleration. Then the distance that would have been covered will be double the time, isn't it? Got it? The logic has to be clear. Anyway, I'll do it with the equation, but you should get this intuition. So whatever acceleration that you had, if the same amount of acceleration was in the opposite direction, then it would have covered the same distance. But in this situation, the deceleration was half of the acceleration. Therefore, it should have covered double the distance which it has already covered, right? So you should get this intuition. Let me use the equation. So the equation that I'm going to use over here is v square minus u square, isn't it? Yeah, that's going to get you the relation between the velocity and then the displacement. So v square minus u square, which is going to be like 2fs. Got it? Over here, the final velocity was v. Yeah. So the initial velocity will be 0, isn't it? The initial velocity was like 0 over there. So you have got like something 2fs, that's going to be v square. So with this situation, the s that it got covered was v square divided by 2f. Okay. I just need to find this new s dash. Okay. I just need to get this new s dash. If I have to get that s dash, let me use this equation once again. That's going to be v square minus u square. That's going to be like 2as. The initial velocity, the final velocity over there is going to be 0 because that's a braking situation. Therefore, you would have got like 0 minus the initial velocity, that's going to be the v over there. So you would have got negative v square, which will be equal to 2. Here you have got the deceleration, therefore it should be like minus f by 2. The logic has to be clear. Negative of f divided by 2, and then you would have got the s dash. This is something that I need to get, isn't it? Yeah, so s dash will be, s dash is going to be v square divided by f, isn't it? These two will get cancelled out, therefore s dash is going to be v square divided by f. So that is nothing but s. If I just multiply 2 to this s, I would have got this s dash. So that's going to be like 2s, isn't it? That's going to be 2s. So here s dash will be equal to double the times of the distance that it has covered in the first part of the journey. So that's going to be s dash, which is going to be 2s. Got it? So you have to be clear with this stuff that I have done over here. You shouldn't have any doubt. It has to be obvious. Even you do not want to use this equation, just by logical thinking, you would be able to get this stuff. It has to be double the time because the deceleration is half of it. Therefore, the distance covered is going to be double the time, right? So that's the logic. Okay. Then what they're asking us to find is if the total distance traversed is 15s. Okay. So this is not second. So that's the little bit confusing part over here. It's not second. It is actually s. Yeah. The total distance that it has covered in this entire journey is going to be 15s. Got it? So if the total distance is 15s, then what would be the in between stuff? So here in between, when it was traveling with a constant velocity v, the distance that was covered will be equal to 12s, because this is like 2s, this is s, therefore you would have got like 12s over there. So the in between distance that it has covered with the constant velocity is going to be 12s. Okay, so now I'm just done with all the stuff that I have to do. Then what you got is, then what they're asking us to find is if the total distance is 15s, then I just have to get the relation that's going to match between s and then the t. Okay, so the s is actually the distance covered in the first part and in the last part. So that is where I can get that relation. What they're asking us is I have to get this s in terms of t. That's what I just need to get it over here. Okay, so I just need to get this s related in terms of this t. Okay, so if I have to get that one, let me use some some equation, kinematic equation to get to that result. So here they're asking us to match between the s and then the time t. Okay, so let me pick this second kinematic equation because I'm just left with only that possibility. That's going to relate between the s and then the time t, because when you look at the relation, that's how it's going to be. Got it? So let me do it over here. So you would have got s, which is going to be, yeah, s, which is going to be half a t square, isn't it? So f t square. I do not know the t over there. As it is first part of the journey, let me take it as t1 square. So s, which will be equal to f t1 square. Okay. So this gives me the first stuff, which is s equals half f t1 square. Now let us look into the second part of this motion. So here the relation is between the 12s and then the time t, isn't it? We just found out the distance is going to be the 12s and they've given you the time to be t. Got it? We also know it's going to have uniform velocity into it, right? So this is going to cover, yeah, this is going to cover distance at a constant pace. Anyway, the velocity that it attained was from the acceleration that was in the first part of the motion, which had a constant acceleration into it, right? So I have to get this velocity in terms of this f so that I can relate between this 12s, t, and then the f, isn't it? Once I relate between this s, f, and then the t, I'll be able to match it with the options that they've given over here. So here, if I have to do that matching, first I have to get the distance that it got covered. So the distance that it got covered was equal to 12s, right? So the distance that it covered was like 12s, which will be equal to velocity multiplied by the time. That's going to be uniform velocity v multiplied by the time. So to get this uniform velocity, which was the final velocity of the first part of the motion, so I have got a relation over here already, right? So that gets you the relation between v, s, and then the f. So if I replace this v in terms of s and then the f, yeah, it should be obvious. The options that they're given has a relation between s, f, and then the t. You have got the t over there, right? So now I'm just ready, yeah, now I'm just ready to get this relation. So let me rearrange this equation that you have got over there. So if I do rearrange this equation, you would have got something like this. V, which will be equal to root of 2sf, isn't it? V was equal to root of 2sf. Let me substitute that V in this above equation. If I do substitute that one, you would have got 12s, which was equal to root 2 fs multiplied by the time t. Order, let me square it on both sides of this equation. If I do square that one, you would have got 12 into 12 s square, which will be equal to, if I do square over here, you would have got 2fs multiplied by the t square, right? Now just let me cancel out something that's going to be constant in both those sides. So s and s will get cancelled out. Then this 12 and then this 2, you would have got 6 over there. Yeah, right. Yes, everything is done. Let me rearrange it. You'll get the answer. So you will get s, which will be equal to f t square divided by, yeah, 12 into 6, right? So 60 72. You would have got like 72. So s will be equal to f t square divided by 72. So this should have been my answer. So the answer is f divided by 72 multiplied by t square. Let me verify it with the option. So if you look at the option, none of the option is matching with the answer that I've got, which means none of the option is correct over here. So if you get such a kind of question, you have to leave it. If you leave it, they will reward you with the full mark. Got it? If you end up marking one of the answers, then they'll give you the negative mark because none of the options were right. You ended up marking one of the answer. So obviously you'll get the negative mark, right? So rarely you'll get such a kind of question. You can't expect such a kind of question in the examination. So in the world, yeah, very old questions, you have got such questions where you got mistakes into it, right? Fine. You shouldn't get doubt on this question. It has to be clear. Yeah, simple solving over there. I just got the relation between s and then the velocities. That was the third kinematic equation. Then to proceed further, yeah, it was the final velocity of the first part of the motion was the velocity that was needed for the second part of the motion. So the distance covered was the velocity multiplied by the time. Just instead of that velocity, you just plug it in all those yes, and then the F combination that we have already got. Just do the solving, you'll get the answer, right? Nothing more to it. You have to be clear with this question. Let's move on to the next one. This question is simple one, logic based question. Let me read it. From a building, two balls A and B are thrown such that A is thrown upwards and B downwards. So there is a guy who is standing on a building and then he is throwing the ball such that one he is throwing downwards and the other one he is throwing upwards, both vertically, which means along the y direction with same speed. Okay, so that's the hint. So the speed is going to be same, which means with whatever velocity he threw upwards, the same velocity he threw it downwards. Got it? So the magnitude of that velocity is going to be same. Got it? If VA and VB are their respective velocities on reaching the ground, then so I just need to get the final velocities of those two balls. One, one of the ball. Let me consider the A ball, which he threw upwards. Got it? With an initial velocity u. Same way he got the other ball, which he threw it downwards with an velocity u. Okay, we just know this ball it just goes straight to the ground and hits the ground with certain final velocity. That's gonna be V B. Got it? But with the case of this ball, it's going to travel upwards and then it's going to come to its same position and then it's going to move downwards and it will hit the ground. Got it? So when it reaches the same position where it was thrown upwards, we just know, yeah, it will have the same velocity but in the opposite direction. You do not have air resistance, nothing into it. Therefore, I have to idealize the situation. And by the way, there wouldn't be any energy loss into it. We haven't learned energy loss. We'll do it in upcoming chapter. As if now we just know by the intuition with water velocity that I threw upward, it has to come with the same velocity, unless you do not have any other energy loss to the surrounding, right? Got it? Because whatever height it reached, because of this velocity, once it comes back to its initial position, those height has to get converted to the velocity, right? So it will have the same amount of velocity but in the opposite direction, right? The intuition has to be clear. Therefore, when it reaches the same position, it will have the same velocity u but in the downward direction. So here, when it is about to reach the ground surface, that too will reach the ground surface with the same velocity of this VB. Therefore, VA will be equal to VB, right? So this is something, this is like a logic based question. You have to be clear over here. Simple one. So the velocity for both those balls is going to be same as it was having the same velocities, magnitude of speed into it, right? Got it? Therefore, the answer here is option 2. You shouldn't have any doubt on this question. Easy one. Let's move to the next question. From now onwards, you'll get numerical type question. You got around like 4 or 5 questions that I've chosen for you. So this 28th question is, a body moves on a frictionless plane starting from rest. So you're having a plane and that frictionless plane, there isn't any friction. What it's so while doing the next, I mean, laws of motion chapter, I'll tell you, we'll learn in detail about this friction, the inclined plane, and all those stuff. As if now it's not going to play any important role for this question. So you have got a plane, and then there is a block that's going to slide in this plane. And by the way, that plane is frictionless. Your body moves on a frictionless plane starting from rest. Initially, it was at rest. If Sn is the distance moved between time t equals n minus 1 to n. Okay, so Sn is the distance traveled in the nth second. Okay, so in that particular second, if it was like S8, in that 8th second, how far it has traveled. So 8th second actually means the distance traveled between the time interval of 7 to 8. Okay, so that's what they have given you clearly. If Sn is the distance moved between t equals n minus 1 to t equals n. Okay, so 7 to 8. And Sn minus 1 is the distance traveled, is the distance moved between t equals n minus 2 and t equals n minus 1. Okay, so that's the before one, which means between the interval 6 to 7. Got it? Simple one. Yeah, this is something that we have already discussed in the theory. Then you have got then the ratio Sn minus 1 divided by Sn is 1 minus 2 divided by x. Okay, so they've given you this ratio straight away. So I just need to get this ratio, which should be equal to 1 minus 2 divided by x for n equals 10. So they have given you the value for n, that's going to be like 10. Okay, the value of x is, I just need to get what will be the value for this x. So that's what I need to get it over here. Got it? So if it was this inclined plane and this is gonna fall, this is gonna slide along this inclined plane. it will have an acceleration which will be equal to g sine theta, and this will be my theta. Do not want to worry about this g sine theta, all those stuff. We'll do it in upcoming chapters. Yeah, that is something that will get used to it. Anyway, those stuff are not gonna be important for solving this question. So the formula that you need to solve for this question is S, which will be equal to U plus half A 2n minus 1, isn't it? U plus half A 2n minus 1. If it was acceleration due to gravity, then I would have plugged it my negative g straight away into it. So do not want to worry about that negative g. So it's gonna be like U plus half A 2n minus 1. Anyway, A will get cancelled in this question. Got it? Yeah. What they are asking us to find is Sn divided by Sn minus 1, isn't it? So for the first equation, you would have got this one straight away. There wasn't any initial velocity into it. Therefore, for the first equation, you would have got Sn, which will be equal to half A 2n minus 1. If it was g, then I would have put negative g into it. It will get cancelled out. Then you would have got Sn minus 1. So what should be Sn minus 1? That's going to be half A 2n minus 1, isn't it? Okay, so these are the two equations that is needed over here. Fine, got it. So what they're asking us to find is the ratio between Sn minus 1 divided by Sn, isn't it? So they're asking us to find the ratio between Sn minus 1 divided by Sn. That's going to be equal to 1 minus 2 divided by x. Okay, let me do the solving, you'll get the answer. So I'll have to divide it by Sn. That's going to get you half. Okay, I'm just going to repeat it one more time. 2n minus 1. So here half will get cancelled out. A will get cancelled out. Then if I do the inner multiplication over there, you would have got 2n minus 2. Yeah, so you would have got like 2n minus 2 and then one more minus 1 to it. So that's going to be 2n minus 3, isn't it? So here this is going to be 2n minus 3 divided by 2n minus 1. This one has to be equal to something that they're given in the question, which was 1 minus 2 divided by x, isn't it? So here you would have got 1 minus 2 divided by x. 1 minus 2 divided by x. See, for this question, they have also given us you have to take n to be 10. So here I'll just take n. That has to be equal to 10. Okay, if I do substitute that one, you'll get the answer. That's it. Let me do the solving. You'll get the answer straight away. No more thinking to it, no more tricky parts. Just a simple straightforward solving. So I've got x minus 2 divided by x, which will be equal to, if I substitute 10, yeah, if I substitute 10, you would have got 20. Yeah, right? Yes. So I do not want to do the solving. That's going to be extra one step to it. Let me take it 1 minus 2x itself. 1 minus 2 divided by x. If I substitute 10 over there, you would have got 20. 20 minus 3, that's going to get you 17. Yeah, that's right, isn't it? Yeah, 20 minus 3 is going to be 17 divided by, here you would have got like 20. 20 minus 1, that's going to get you 19. Okay, so if I do rearrange this one, you would have got 1 minus 17 divided by 19. That's going to get you 2 divided by x. Yeah, cross multiply it. 19 minus 17, that's going to give you 2 divided by 19, which will be 2 divided by x. These two will get cancelled out. Therefore, x will be equal to 19. That's going to be my answer. Fine. So what you have to do is, this is a computer based test. Therefore, just type 19 in the keyboard for this fill in the blanks. The answer here is 19. Got it? It has to be clear. A simple one, right? So just use this equation, s equals u plus half a to n minus 1, you'll get the answer. That's it. Then just take the ratio and match it with one of the fraction that they're given in the question. You'll get the value for x, right? It has to be clear. Simple one. Let's move on to the next question. Next question is, a body falling under gravity covers 2 points A and B separated by 80 meters in 2 seconds. So you're just going to drop a ball from certain height. Got it? So it is moving under the influence of gravity. There was an instant where it was able to cover 80 meters in 2 seconds. Fine. So that was a journey in between. the motion. Got it? It was in the initial 2 seconds where it was able to cover 80 meters. That's not going to be the case. In between two points A and B of its entire motion, it was able to cover 80 meters, that too in 2 seconds. So that's the hint that they've given in the question. With that, I have to solve it. Then what they're asking us to find is the distance of upper point A from the starting point where it was dropped. So I just need to get the distance between the point of drop and then the position A. Okay, so what will be the distance between origin and then the A? That's what I need to get over here. And I have to get it in meters. I can use G to be 10 meter per second square, right? So let me draw the diagram, we'll get it. So here what I'm going to do is I'm just going to drop a ball at the origin, ball or body, whatever it is, and then in its entire motion of its journey, got it, there was two, I just chose two different points. Okay, that's going to be A and then the B. This is like point A and this is point B. In between this journey, I was able to cover 80 meters. In between this journey, I was able to cover 80 meters. The time taken for that 80 meter will be like t equals 2 seconds. So the time taken for that journey will be like 2 seconds. What I need to get is the distance between the upper point, distance between the point A and then the starting point or the origin. That's what I need to get. So something that I need to get over here is this distance. So this is S, which I need to get. Got it? So if I have to get the distance, what I need to know is, so they have given everything in terms of second. Therefore, the equation that I could use is like S equals ut plus half at square. The initial velocity over there is obviously 0. Therefore, you would have got S equals half gt square. Just do not want to worry about this negative sign because the entire motion is in the downward direction, right? So do not worry about the negative sign. Got it? So here I, I I just need to get this S. If I have to get this S, that's going to be S equals half gt square. So the time taken for the first part of the motion is going to be t. Okay. So the time taken over here is like t. And for the second part of the motion, which will be like OB, that should be S dash, which is going to be S plus AT. Okay, so let me write it for the second part of the motion. That's going to be S plus AT, S, which will be equal to half. Here, the G is going to be, okay, G10, whatever it is, T square, right? So instead of T, let me substitute T plus 2 the whole square, right? So that's going to be the new time, or T dash. So T dash will be T, the initial time, plus this 2 seconds. So that's going to get you T plus 2 the whole square, right? Fine. So now I've just got two different kinematic equations. Just solve it, you'll get the answer, right? Yes, you'll get it. So I just need to get S. Yeah, I just need to get S, isn't it? So let me solve this equation. If I do solve it, I'll get the answer. So here, to solve this one, I just know this one, S equals half gt square, right? So let me substitute half gt square straight into this S. You'll get an equation that just only have T and then the G. For G, I'll substitute 10, I'll get the answer. That's it, finished. Fine, just a little bit of solving, I'll get the answer. So I've got half gt square, which is going to be half gt square plus 80. That's going to get you half. Let me, yeah, half g. Let me square it. If I do square it, you would have got, if I do square it, you would have got something like this. T square, yes, plus 4 plus 4t, isn't it? Yeah, let me do the inner multiplication. Once I get the t, I'll be able to get this s equals half gt square, because once I get the t, if I substitute t over here, I'll end up getting this s. That's it, finished. Okay, so let me solve it on. Let me do the inner multiplication. You would have got two more steps. Half gt square plus 80 will give you half gt square plus half multiplied by 4g plus half g 40, isn't it? So now let me cancel out this one. You have got half GT square, half GT square. Those two stuff will get cancelled out. Yeah, just next is I have to do this all along, isn't it? Yeah, T is something that I need to get. Let me substitute 10 for this G. If I substitute 10 over there, so what will you get? So this will get cancelled out. You would have got like 5. 5 is a 20. So you would have got 20 for this stuff. And then here you would have got these two stuff will get cancelled out. You would have got 5. So same. Yeah. So same. So 20 T. This is going to be 0. This is going to be 80, right? So 80 minus 20, that's going to get you 60. 80 minus 20 is like 60, which will give you 20 T. So T will be equal to 3 seconds. Now I've got the time T. Yes. So once I know the time T, just substitute this time T into this main parent equation that I've got. So that will give you the S. So the S over here will be half 10 3 square, isn't it? So you would have got 90 divided by 2, that's gonna give you 45. Yeah, right, 90. Yeah, 90 divided by 2, that's gonna get you 45 meters. So the answer here is 45 meter. For this question, that's 45 meters. You have to be clear with this question. Simple one. Yeah, you have to get the diagram right. So if you get the question right, you'll be able to get the answer. Simple one. So S equals ut plus half at square. That's the equation that I used. Got it? So you have to get this one clearly. The point AB is not the starting point. It's something in between. So in that in between interval, it was able to cover 80 meters. The time taken to cover that interval was like 2 seconds. So if you get this logic straight correctly, you will be able to get the answer, right? Got it? You shouldn't have any doubt on this question. It has to be clear. Let's move to the next one. This question is a little bit tricky one. Let me read the question. Your body starts falling freely from height h, hits an inclined plane in its path at height small h. Okay, so first let me draw the diagram for this question. So you are having an inclined plane, alright, and then you have got a body that's falling from an height h. So you are having an object that's gonna fall from an height h. So the distance over here is height h. Okay, so that's the distance over there. And then what's going to happen over here is it hits an inclined plane in its path at height small h. Okay, so it's going to hit the inclined plane at a height small h. So this distance is going to be small h. So this is where it's going to hit the inclined plane. So a body which is falling freely from a height capital H hits an inclined plane in its path at height small h. Got it? As a result of this perfectly elastic impact. So this is a hint over there, which is like this is a perfectly elastic impact. The direction of the velocity of the body becomes horizontal. So this is perfectly elastic collision. And then here what's going to happen over here is the direction of this velocity of the body becomes horizontal. As soon as it hits this wedge, it's going to have the horizontal velocity. Okay. So it hits and then it's going to have the horizontal velocity v. Fine. Okay, the value of capital H divided by small h for which the body will take the maximum time to reach the ground is. Okay, so how should the ratio be with respect to capital H divided by small h so that it's going to take the maximum height to reach the ground. So I have to get this ratio which is like capital H by small h. See, if you get such a kind of question where they're asking you to get the maximum time or the minimum time, what you should do is you should generate an equation. If they have given you the equation straight away, just differentiate it and equate it to 0. Either you'll get the maximum or the minimum. But in the question, if they have given you clearly that's going to be the maximum, then obviously the time will be maximum. If you have to verify whether it is maximum or minimum, you have to do the double differentiation of that equation. If the answer is like positive, then that's the minimum point. If the answer is like negative, then that's the maximum, right? So we will generate an equation and then I'll equate it to 0, right? Once I equate it to 0, you'll get this ratio capital H by H that's possible for me to find. So that should obviously be the maximum time. If we have to verify it, then do the double differentiation. If the answer was like negative, then it is like maximum. Okay. Got it? So we have seen this theory already in the, we have seen this logic already in the theory part. So that was the extra math logic that I did teach you. So we will use this math logic more of often in the upcoming sums that we are going to solve in the different chapters. Got it? So you'll get used to this kind of intuitions, right? So if they have asked you to get the maximum or minimum time, something that needs to strike you, which is going to be differentiating it and equating it to zero, right? Got it? Fine. So you have to be clear with this question. So I'm just going to drop it, and that is going to be a perfectly elastic collision. Because of this perfectly elastic collision, with whatever velocity it hit this wedge, it's going to have the same velocity but in the horizontal direction. Okay, so this velocity is not going to be useful anyway. Something that was crucial over here is it's going to have the horizontal velocity. Okay, got it? So I'll use that hint. Fine. So let me get this first let me get this equation. So they're asking us to find the time t, and they're given us the relation for the displacement. So obviously I have to use the second kinematic equation. That's going to be S, which is equal to half g t square, isn't it? So sign doesn't come into picture, because if height h was like negative, then obviously you get one more negative g. Negative negative, it becomes positive. Therefore do not want to worry about the sign, just the magnitude. Just play with the magnitude, which will get you the answer, right? Okay. So now for the first part of the motion, so this will be the first part of the motion. I just know the total height from the bottom is going to be capital H. That was the height H where it was dropped. And then it hits the plane at its path at height H, right? So where it got hit this, where this object was able to hit the plane, the height was like capital small h from the ground surface, isn't it? So what will be this in between height? So the in between height will be capital H minus small h, obviously. So to reach this point, it would have taken a time t1, right? So here it's going to be capital H minus small h. That will give you half g t1. So this time t1 is something that I gave because that's the first part of the motion. For the second part of the motion, that will be time t2. Summation of t1 plus t2 will give me the total time. Got it? Okay, so capital H minus small h, half g t1 square. So here I just need to get the time t1. Therefore t1 will be equal to 2 capital H minus small h divided by the g, isn't it? Yeah, now I have generated this equation. T1 equals 2 capital H minus small h divided by g. You should be clear with this idea. Then for the second part of the motion, yeah, for the second part of the motion, so here what has happened is this entire velocity became horizontal. Then in this situation, there wasn't any velocity that was acting downwards. So here in this situation, the vertical velocity became zero. Therefore, this is a kind of situation where the initial velocity can be considered to be zero, because again it's going to accelerate downwards as like a fresh start. Okay, because all the velocity got transferred horizontally. Got it? So you will get used to this idea in the next chapter, projectile motion. So in the projectile motion, we will split the velocity into two components, vertical and then the horizontal. When we do split that one, only the vertical component will be responsible for the vertical motion. Horizontal will not help. Okay, so in this situation also, it's a kind of new motion dropping from the from that particular point. Okay, therefore for the second part of the motion also, the initial velocity was zero, right? So here also, as the initial velocity was zero, because the entire velocity became horizontal, right? So this might be something new and confusing right now, but you'll get used to this idea from the next chapter onwards, right? So even for the second part of the motion, the initial velocity was zero. Therefore you would have got, yes, I mean small h, that will be equal to half g t2 square, isn't it? Yeah. So to get this T2, that's going to be 2h divided by g, right? So now I have got, and it's under root. I've missed this root over there. It's under root. Yeah. So now I have got these two equations. So time t will be equal to, I just know this one, right? Time t will be equal to t1 plus t2. Just do the summation, you'll get the time. So the time t was equal to t1 plus t2. So t1 was root of 2h minus h divided by g plus root of 2h divided by g, isn't it? Now I have got this equation. See, once you get this equation, I have found the relation between the time and then the h, where capital H is constant, G is also constant. I've got this equation. What they're asking us to find is the maximum time. Okay, so if they are asking you to find the maximum y or minimum y has to be in the numerator, y has to be in the y-axis, and x will be in the x-axis, obviously. So here that will give you like dy by dx, right? So here also something that I need to find to be maximum or minimum has to be in the left hand side to the power 1, whatever it is, but you have to differentiate with this. I mean, you have to make this as the numerator in the differentiation, and you'll have to differentiate with respect to h. Okay, so here as I have to find the maximum time, I'm just going to differentiate it with respect to the h that's considered to be the x-axis, right? You have to get this idea. In the theory part, while I was discussing this maximum and minimum, I was finding like dy by dx, right? So what I was finding over there is what was the position with respect to which will be the maximum position for the y. Okay, same way maximum or minimum position with respect to the y. Same way here also, I'm just going to get the equation for the maximum time. Got it? So I have to differentiate it with the other variable, which is going to be h. So the differentiation that I need to make over here is dt by dh. You shouldn't make dh by dt. That's not possible. Then it will go to infinity. That's not possible for me to solve. Therefore, what they're asking, first you have to get that question. What they're asking is to find maximum and minimum with respect to what? It's with respect to the time. Therefore, I have to place it as numerator in the differentiation. I'll have to differentiate it with the other variable. So the other variable over here is like h. Therefore, I have to differentiate this equation with respect to h. So if I do differentiate this equation with respect to h and equate it to 0, I'll end up getting the relation between capital H and then the small h, right? So let me do it. Before differentiating this one, let me factor out the common term in both those terms. So the common term over here is like root 2 by g, that is common and it is constant, right? So let me factor out that one. Root 2 by g. So inside the bracket you would have got root of capital H minus h plus root h. Okay, capital H minus h root h. So this is the time t. Let me differentiate this equation and I'll make it to 0. So you would have got dt divided by dh, and then I have to equate it to 0, isn't it? If I differentiate this equation, you will get root of 2 divided by g. When it goes to other side, right hand side, it becomes 0. So let me leave that one. Then you have got capital H minus h power 1 by 2, right? So small h is the differentiable element, or small h is the differential element over here, isn't it? Capital H is the total height, so that's not going to be change. So if I have to differentiate this one, I'll just make this entire term as x, isn't it? So x power 1 by 2. So you would have got half root of capital H minus h, and then I'll have to differentiate this term which is inside the root, and I'll have to multiply it, right? If I do differentiate this one, I'll get like negative 1 because I'm just differentiating it with respect to h. This term gives me the negative 1 and I put it over there, right? So that one has to be clear. Then for the second term, you will get root h, isn't it? That would be half for the root h. I've missed the power over there, isn't it? So the power over here is like negative 1 by 2, isn't it? Minus 1 by 2. Because n x power n minus 1. So n x power n minus 1, that will give you minus 1 by 2. Same way here, half h power negative 1 by 2. That's okay. Then differentiating it one more time, that's the same thing, right? Okay, so that will give you which is equal to 0, right? So just rearrange this equation, you'll get the answer. So if I do rearrange this one, so this half, that's a constant term, everything will go to 0. You'll just only be left with 1 divided by root of capital H minus h, isn't it? Plus 1 divided by root of h. Yeah, I've missed the negative sign over here. So negative 1 divided by root of capital H minus h, and then you would have got like 1 divided by h, that goes to 0. Fine. So let me rearrange this one. If I rearrange this one and square it, you will get 1 divided by capital H minus h, that will give you 1 divided by h. Okay. What they're asking us to find is the ratio between capital H and then the small h, isn't it? So to get that ratio, yeah, so to get that ratio, just do the cross multiplication. You will get capital H minus H. That will, yeah, just flip it. That's it. Capital H minus small h. That gives you H. So this one will give you capital H. That's going to be like 2H. What they're asking us to find is capital H divided by small h. So that will be capital H divided by small h. So that's going to be 2. So the answer here is 2. So the number that you need to type is actually 2, right? Yeah, the question has to be clear. You shouldn't have any doubt in this question. I've told you, like, it's a tricky one. So here, what they're asking us to find is the maximum time. So when they ask you to get the maximum or minimum, first you have to generate the equation, right? So once you generate that equation, with respect to time over here, so you have to keep this one in mind. So how should I do the differentiation? Something for which they're asking us to find maximum or minimum should be in the numerator of the differential. Okay, so here it should be like dt divided by dh. You do the differentiation, so be careful while doing the differentiation and equate it to 0. Once you equate it to 0, you'll end up getting the answer. That's it, finished, right? Yeah, it's a quite tricky question. You shouldn't have any doubt on this question. Let's move to the next one, which will be the last question for this session. The 31st question is, a ball is projected vertically upwards with an initial velocity of 50 meter per second. So I'm going to throw a ball vertically upwards with a speed 50 meter per second at t equals 0. So that was the starting time. At t equals 2 seconds, so after 2 seconds, another ball is projected vertically upwards with same velocity, right? So first I just threw a ball, then I waited for 2 seconds and then I threw the next ball. At t equals 2 seconds, the second ball will meet the first ball. At t equals what seconds, the second ball will meet the first ball. So when these two balls is going to collide, that's what they're asking us to find. So I just need to get the time at which the first ball is going to collide with the second ball. Got it? So here you have got a ball and then I throw it upwards. The time t was equal to 0. Okay. Then after 2 seconds, so this will be at some different position when time t equals 2 seconds. I just threw the next ball. Okay. So after t equals 2 seconds, so that was a new t dash. Okay. Then there will come a point. I just threw on the same vertical direction, isn't it? So here the first ball has traveled some distance to the top, after which the second ball is following. So we know, and by the way, the initial velocity for both the ball was same. Okay. By the way, there will come a point where this first ball has reached its maximum point and then it will start falling down and this one will be traveling upwards. Okay. So there will come a point where the ball that I threw earlier is going to collide with the ball that's going to following down. Okay. So they're asking us to find at what time these two balls are going to meet each other, right? So to get this one, I obviously know the equation that I need to use over here is the second kinematic equation, because that's where I'll be able to relate between the displacement and then the time, isn't it? So the equation that I'm going to choose over here is S equals qt plus half at square. Before solving this equation, you have to get an intuition behind this equation, which is this is actually sign sensitive. This equation is direction sensitive, which means it gives you the exact position of that object with respect to the time. Okay, so let me explain you. So initially, I know I just threw this ball upwards with an initial velocity of 50 meter per second. So that is not right. So let me consider, I'm just randomly choosing numbers over here. Let me consider at 1 second this you would have got some u into it. So that initial velocity is like 50. So 50 into 1. So that's going to be this term, right? So 50 into 1. So when you look at this equation, so obviously this term is going to be negative, right? So if it is going to be negative, so you will get, yeah, 5t square, whatever it is, 10 divided by 2, that's going to be like 5. So you would have got like negative 5 over here, right? So initially this term is going to be much more greater. This is like negative 5, right? So the displacement that it has covered in the positive direction will be like 45 meters, something like that. Okay, so it would have covered like 45 upwards in the first second. Then when u equals 2, you would have got like 100 to it, and then you would have got some other number to it, right? So that is how these two parameters are going to play, and there will come a point in time where it will reach its maximum height. So that will be the maximum height that is possible to reach over there, because the sum that would be the, see this stuff, the second term is actually increasing in square, but when you consider the first term, that is only to the power 1. Okay, therefore there will come a point in time where this will reach its maximum height. Okay, so here it will be like 50 minus 5, next it would have been like 100 minus some 20, something like that. So this s is going to increase upward, and there will come a point where this will reach its saturated value. Okay, it can't increase much more greater, but this will increase at a very rapid pace. Okay, so then what will happen is this will start falling down. So when it was about to fall down, this term, negative term, will start dominating, and it will not be able to, I mean, you will never get a value that is greater than this maximum height. So it will start moving downwards, right? Fine. So this term, when you do the addition of these two term, obviously this is going to be subtracted. So when you subtract these two term, you will get value that is less than that of this maximum height, and then it will start moving downwards, right? So then this t will just increase rapidly when compared to this one. Therefore the next point is going to be less than this, and there will come a time when it will reach its origin, which means there will come a time when this term and this term is going to be same, and they are going to be opposite to each other. Therefore these two stuff will get subtracted, and you will get the s to be 0, right? So this gives you the position of the object in its entire motion. Got it? You have to be clear with this idea, right? So this is how we imagined and we did this graph sum, right? So that's what I'm telling you over here, right? So this gives you the entire position of the object with respect to the time in its motion, right? So you have to be clear with this understanding. So for the first equation, s equals ut plus, you do not want this one. So for this first equation, s equals ut plus half at square, I just know the initial velocity will be like 50, and there will be a time where the position of this first ball and the position of the second ball is going to be same. So when you get the position of this first ball and second ball to be same, that will be the point where this is going to collide. Okay, so what they're asking us to find is at what time it's going to get collide, right? So at the time when it is about to collide, you will have the same position for the first ball and then the second ball, right? So the hint over here is during the collision you will have the same s for both those balls, but with the case of the first ball it would have traveled up and then it would have come down, but with the case of the second ball it is still in the upward motion, but both those stuff got collided, right? So what will be the time when these two balls are going to collide? That's what I need to get over here. So simple sum solving will be simple. Just figure out the displacement second kinematic equation for both those condition, and then just equate, because when you do equate, the s is going to be same. That's it, finished. Okay, for the first it's going to be s equals ut plus half at square, and then for the second motion it's going to be s, same s, because that's going to be the same. So you would have got s equals u t minus 2, isn't it? Because this started 2 seconds late of the first ball. Okay, so this is like 2 seconds behind of that first ball, therefore you would have got like t minus 2. So that will be my t dash over here, isn't it? So this was my t. When t equals to 0, it was thrown. After 2 seconds I threw the second ball, which means this equation, in this equation I'll have to plug in t 2 seconds less than that of the first condition, right? The logic has to be clear. So plus half, okay, a t minus 2 the whole square, right? So now I can equate these two equations, just substitute g and everything into it. So for the g you have to be careful, this is sign sensitive, therefore you have to substitute negative g. When the entire motion was in downward direction, just plugging in two negative sign will give you the positive answer, but this is not the case over here. I've already explained you, one has traveled upwards and then when it was returning back it collided with the second ball, right? The reason is because the second ball was thrown 2 seconds later to that of the first ball. That's why when the first ball was returning, the second ball collided with the first ball, right? Logic has to be clear. This equation is sign sensitive. I've explained you, right? You have to be clear with that logic that I've told you. So initially the first term is going to dominate, therefore the motion will be upwards. Then there will come a point in time where the second term will start dominating. Then that maximum height, that will be the maximum positive value that I'll be able to get. Then after which the second term, even though the answer is not going to be negative, the second term will be greater when compared to that of the first term. Therefore, the positive term is going to decrease, and there will come a point in time when these two terms will be 0. So that will be the time when it will reach again its origin, right? After that, the entire term will be in the negative direction, right? So that's how it has to be, right? Got it? You have to get this understanding behind it. Now let me equate these two equations. Once you equate it, you'll get the answer. So the equation is going to be such that ut, that's going to be 50t minus half 10 t square, which will be equal to ut minus 2u ut. No, let me substitute 50 over there. So you would have got 50u 50t 50t minus 100, okay, minus half 10 t minus 2 the whole square. So here only one term is left, which is like t. That's what they're asking us to find, right? So just solve this equation, we'll get the answer. That's it, finished. So 50t will get cancelled out, and then I have to expand this equation and do the solving. You'll get the answer. So if I do, let me cancel this one also. So this will give you like 5. So this will give you like 5. If I do expand this equation, you would have got t square, right, plus 4 minus 4t, right? Yeah, 2ab. Yes, just do the inner multiplication and equate it. So on the left hand side, you would have got 5t square, negative 5t square, right? Negative 5t square, and which will be equal to minus 100. Yeah, that stuff is done. Then here you have got negative 5. As if I do the inner multiplication, you will get minus 5 t square minus 20 plus 20t, right? Let me solve this. Minus 5t square minus 5t square minus, that's going to get you 120, isn't it? That's going to get you 120, which will be equal to 20t, right? Zeros will get cancelled out, and then time is going to be 6 seconds. 6, right? So time over here is t equals 6 seconds. At the 6th second, the first ball will collide with the second ball. So t will be equal to 6. Okay. So the answer over here is 6 seconds. At the 6th second, the first ball will collide with the second ball, right? So the first ball will actually move downwards, the second ball will be moving upwards, and these two stuff are going to get collided, right? It has to be clear. You shouldn't have any doubt in this question. Fine. So the way we solve this question is actually easy, but the understanding behind it is something that you need to get. Okay. So this equation is actually sign sensitive. It gets you the direction. While doing graph itself, in the last session, while we were doing graph, I just substituted it h2 minus h1. So while doing that itself, you should get that intuition. It was like sign sensitive. Same way here also it was sign sensitive. And then I did explain you one term with respect to the other term. You have to get that logic clearly. That is when you'll be able to understand this one clearly with intuition behind it. Just the equation is something that's easy, right? So get the two s. If it has to collide, s has to be same for both those ball. That is when it's going to get collided, right? So at that point, these two stuff will get collided. That's it. You'll get the t. So the time was equal to 6 seconds, right? You shouldn't have any doubt in this question. It has to be clear. So that will be the last question for this session. By now, we have to be clear with all the sums that we have seen in this session. And by the way, you have to be clear with all the 31 sums that we did see. Got it? Yes. So they were complicated. It wasn't as easy as it was in the case of NEET. The solving part will be much more tougher when compared to that of the NEET that you might have felt while solving it. Anyway, the sums that we did see in the session were related to the differentiation and equating it to 0. We did get the minimum, maximum, got it, and we solved mainly sums that were related to the kinematic equations. And in this session, we did the numerical type questions. We did around like 4 numerical type questions. You have to be clear with all the questions. So once you are thorough with all these different pattern of solving that we did, yeah, you can try your own self. As I've already told you, I'll just attach attachment file and in the description section of these videos. Okay, so you can download those files. So one part will be this question, so you can practice solving while I'm teaching you. So you can get the PDF. You can just work out the sums that I'm working out in the class in these sessions. And you'll also have one more extra attachment file or the PDF that attachment file will be something that you need to solve. Got it? So you have to work those 25 questions. I'll give you around 25 to 30 questions. You have to solve all those 30 questions and just try to get as much as questions right. Got it? You obviously you will not be able to do all those 25 or 30 questions. It's going to be a little bit tougher. Anyway, so if you are thorough with all these questions that I've taught you, you will be able to solve max number of questions in the practice problems. Those practice problems will also be previous year JEE questions. Okay, so they will also be equally competitive and tough to that of the sums that we have seen over here. I have done all the different pattern sums that they have asked. Okay, so once if you are thorough with all these different pattern sums, most probably you will be able to solve max number of questions in the practice sets that I'm going to give you, right? Okay, so you will also have those practice set in the description section. Do download it and check it. By the way, I'll give you the solution also, right? So just solve it by yourself. Try to get the answer as much as possible. If you feel some of the questions are tough to solve, get to the solution. Just give a glance. Just verify with the solution. Then practice it one more time. That's it. Finished. You are thorough in this chapter for the JEE examination. So this is the maximum preparation that we could do for an examination. And then by the way, you have done it successfully, right? Fine. Okay, with this the video gets completed. Bye.